Most history is taught as a sequence of isolated empires, rising, peaking, and vanishing. A civilization grows its borders and eventually collapses into ruin. This chart is the World Geohistogram. It provides a macro-level view of human civilization across time, mapping distinct political entities against geographical regions. Read traditionally, the document displays vertical bands of color representing independent societies expanding and contracting over the centuries. Under the Brain Kinematics Model, a framework used to analyze complex networks, these shapes reveal something entirely different. Civilizations are not static entities. They are temporary, stable attractors within a continuous global field of geopolitical strain. Every structural bulge on this timeline is a large-scale strain package. It is a concentrated node that has successfully organized and metabolized localized pressure from resources, populations, and technology. In this framework, collapse is a misnomer. Populations do not vanish. Infrastructure doesn't evaporate. Trade routes survive. Collapse is a phase transition where accumulated strain is redistributed into new successor nodes. By translating this visual history into precise mathematical models, we can extract the specific variables that dictate these phase transitions and apply them to evaluate the stability of our current geopolitical order. Calculating the next global reorganization requires discarding the concept of isolated empires. Human history is a continuous, dynamic strain field. Look closely at the specific bulge representing the Roman Empire. Its physical shape on the chart provides the baseline variables for measuring civilizational expansion. This master equation calculates the magnitude of civilizational strain at a given time. The total width of the package is determined by its active inputs and subtractions. The positive generation inputs rely heavily on physical capacity, the system's ability to integrate available resource potential, and the concentration of its labor mass. Those raw inputs are multiplied by two structural factors: organizational coherence, meaning administration and law, and route connectivity. These variables allow the package to physically widen and absorb new territories without breaking apart. Operating against these multipliers is the subtraction variable, internal dissipation and disorder. This accounts for administrative overload, inequality, and institutional friction. A system visibly narrows on the timeline when it crosses a strict threshold. Internal loss and outflow to rival nodes exceed the internal generation of strain. The Roman system eventually reached a state where it could no longer metabolize incoming pressure from borders and economic demands. The system fractured, transferring its stored strain into Byzantine and early European successor packages. The width of an empire on a historical timeline measures its capacity to metabolize geopolitical strain without suffering a phase transition. Expanding our view across the entire dataset reveals a macro-historical pattern linking these dominant packages. Tracing the thickest bands of integration from Mesopotamia through Persia, Rome, Western Europe, and the United States isolates what we call the moving spine of superpower coordination. We calculate this using a weighted center of civilizational mass. The equation combines the exact spatial coordinates of a dominant power center with its total strain weight. By calculating the sum of these positions and weights across all active nodes, we pinpoint the mathematical center of global integration at any given point in time. This allows us to track two kinematic indicators. The first is velocity. A low velocity reading indicates a long duration of stable directional influence, where one regional center successfully coordinates global systems for centuries. The second indicator is acceleration. Periods of high acceleration mark rapid historical transitions, where the capacity to process strain transfers quickly from one geographic node to another. The critical warning sign is high curvature. When the trajectory of the center sharply bends, it dictates a major global redirection, or a bifurcation where a single node splits into competing attractors. Global hegemony is a physically measurable, migrating coordinate of maximum systems integration. In our contemporary era, extreme levels of global technological and economic interconnectedness have completely shattered the older single unipolar spine. The modern superpower topology has distributed its mass into a multipolar polygon. The primary nodes are centered on the United States, the European Union, China, and India, with Russia acting as a heavy military geostrategic pressure node. This is the global strain vector map. We are no longer tracking single points of mass, but calculating a continuous global vector field, where every region sits under the combined pull of multiple power centers. The magnitude of each vector is derived directly from current datasets. We use International Monetary Fund macroeconomic metrics and CIPRI military expenditure data to plot the exact economic, technological, and military reach of each node. Examining the map reveals distinct visual patterns. Convergent zones, where multiple high-magnitude arrows point inward, indicate high economic or institutional integration. In contrast, rotational basins, where arrows circle around a specific geographic area, identify zones of unstable competition or recurrent systemic crises. The most volatile regions are shear zones. These occur where nearby high-magnitude vectors point in direct opposition, creating extreme fault line instability. Evaluating contemporary power requires mapping the structural tension within this vector mesh, rather than searching for the location of a single hegemon. To predict the behavior of this vector field, we have to move past spatial geography and map the underlying mathematical state space of the global system. This three-axis phase diagram allows us to plot the precise category of systemic stability the world currently occupies. The first axis is global coherence. This measures the presence of shared institutional rules, treaty systems, and baseline economic predictability. The second axis is strain load. This plots the active stress applied to the system from military conflict, economic friction, and supply chain shocks. The third axis maps power concentration, indicating whether dominance is tightly unipolar or heavily distributed across the mesh. Combining these variables yields the stability index. The stability of the entire system equals global coherence multiplied by power concentration, divided by the strain load. Plotting the immediate post-Cold War era places the global system clearly in Region A, stable unipolarity. This state is characterized by high coherence, moderate load, and highly concentrated power. As the timeline advances, the system shifts toward Region B, stable multipolarity. Here, power concentration drops, but global coherence remains high enough to maintain negotiated, rules-based boundaries between rival nodes. However, applying current 2024 data changes the output. Record-high global military expenditures and the active weaponization of manufacturing supply chains have caused a massive spike in the strain load variable, while institutional coherence has simultaneously dropped. Because of this mathematical imbalance, the plotting dot migrates sharply down and to the right, crossing the threshold into Region C, fragmented multipolarity. The physical symptoms of a Region C environment are highly recognizable. The system experiences expanding proxy conflicts, continuous corridor crises, and the breakdown of coordinated macroeconomic action. The mathematics confirm that we are not waiting for the arrival of a new unipolar hegemon. We are actively navigating a structural phase transition into a highly strained, deeply braided multipolar mesh.